Good evening, dear student. Today we shall discuss electric power P, its SI unit, and then we shall establish relationship between power P, potential difference V, electric current I, and resistance R. Now consider this electric circuit. It contains a battery, a key, switch, a rheostat to control the electric current through the circuit, and an electric bulb. When the switch is put on, the bulb begins to glow. Now tell me, from where the bulb has received energy? Obviously, from the battery. It means in an electric circuit, energy is being transferred. This transfer of electric energy per unit time in an electric circuit is called its power. What is power? The amount of energy transferred per unit time in an electric circuit is called electric power. So what happens in an electric circuit? In an electric circuit, energy is transferred, and this transfer of the energy per unit time is called power. You can also define as the quantity of the electric energy consumed by an electric appliance in unit time. The amount of the electric energy consumed by an electric appliance in unit time is called its power. So you can define electric power in a number of ways. The amount of electric work done in per unit time is called electric power, or the transfer of the energy per unit time in an electric circuit is called electric power, or the quantity of the electric energy consumed by an appliance in unit time is called electric power. Now if in T time the amount of electric work done is W, then power P is given by relation so in T time the amount of electric work done or the amount of the electric energy consumed or the energy transferred is W. In unit time, the amount of electric energy transfer will be equal to W over T. and the amount of the electric energy transferred or amount of the electric energy consumed or amount of the electric work done in unit time is called power. So power is P is given by the relation P is equal to W over T. SI unit of work is joule, you're all familiar. Time is second. So SI unit of power is joule per second or watt. Now let us define 1 watt power. 1 watt, if amount of the work done is 1 joule, time t is 1 second, then P is equal to W over T, that is 1 joule over 1 second, that is 1 joule per second or 1 watt. So you can define 1 watt as if 1 joule of electric energy is transferred in 1 second, then the power consumed is said to be 1 watt. Or, sorry, if 1 joule of electric energy is consumed in 1 second, the power of the appliance is said to be 1 watt. If 1 joule of work is done in 1 second, the power consumed is said to be 1 watt. आप अपने लैंग्वेज में डिफाइन कर सकते हो 1 watt को. If 1 joule of energy is transferred in an electric circuit in 1 second, the power consumed, the power transfer being taken place in the electric circuit is said to be 1 watt. Or if 1 joule of electric energy is consumed by an appliance in 1 second, अगर कोई appliance 1 joule energy खर्च करता है, consume करता है 1 second के अंदर, उसकी पावर होगी 1 watt. Multiple unit of watt is kilowatt, and 1 kilowatt is equal to 1000 watt. Now we are going to derive interrelationship between P, V, I and R. We know that V is equal to W over Q. Potential difference across 2 points of a conductor is the amount of the work done to carry 1 unit charge. So if W amount of work is done to carry 2 coulomb of the charge, the potential difference between the 2 points is given by the relation V is equal to W over Q, where V is the potential difference, W amount of work, Q charge. Or W is equal to V into Q. Now we have seen that P is equal to W over T. Substituting this value in this relation, we have P is equal to V into Q over T. Now recall, I is equal to Q over T, or Q is equal to I into T. Let us lowercase use let. So Q is equal to IT. So substituting value in this relation we have P is equal to V into I into T over T, or P is equal to VI. This is the first relation. P is equal to V into I. Now, according to Ohm's law, V is equal to Ri. Substituting this value in this equation, we have P is equal to Ri into I, or simply P is equal to Ri square. This is the second relation. Also, I is equal to V over R. Substituting this value in this relation, we have P is equal to R. I is equal to V over R. So P is equal to, come on, P is equal to V into V over R, or P is equal to V square over R. So these are the interrelation between power, potential difference, current and resistance. First expression is P is equal to VI, second is P is equal to Ri square, third is P is equal to V square over R. That's all today's.